Okay, hello, welcome, good morning, good afternoon, good evening, wherever you're in the world. Thank you for taking time to attend. On behalf of All India Org Users Group, very warm welcome to Sangam 21 virtual conference. Before I introduce today's speaker, most of you know about All India Org Users Group. In short, AIOG is a platform where you can share, grow your knowledge, and network with fellow Oracle community members. Join our social media channels, especially Telegram group, if you need to ask any questions and connect with one of the largest community in the world. As you know, this year's Sangam 13th anniversary and 13 days of non-stop learning. It is years worth of knowledge in 13 days. One of the advantage of running virtual conferences, they were able to bring and connect with world-class global speakers. As you can see from this banner, we have 100 plus speakers, 10 keynote speakers. And so please share with your connections. It's really, really important. And today is a day one speakers. Today is very special day. We have Juan Loaiza as well as it's totally a performance tuning team. And we just had a session from Maria Colgan and followed by many speakers. And also we have a new theme, AMA, Ask Me Anything from Kanar. So we request you to pre-submit your questions in advance. Go to the session page and you'll find a link. And you can also ask it during the live session. And as you know, this is a very important slide. Please take a screenshot of the slide and share with your social media channels so that other people also can join. And I think this is a big list, but important thing is please ask all your questions in the Q&A only and use the chat functionality for any general queries. And particular to keynote session, so we are going to run a 5 quick Mentimeter questions quiz. So please answer, and the top leaderboard guy will get a really, really awesome gift, right? And sentence of the day, as you know, we encourage you to attend all the sessions. Please, capture the sentence of this particular session and form a sentence and submit before 10 p.m. today. And continue your conversation. And also important thing is participate in the speaker survey. When you basically quit from Zoom, it will automatically take you a Survey Monkey link. We really appreciate your feedback, and we will upload the presentation material to the website. So I'll skip this one, and there are a lot of goodies, but we'll talk later. But it's very important. You guys are just watching the introduction video. A very warm welcome to Juan Loaiza, and also welcome to Maria. Juan Loaiza is the Executive Vice President of Mission Critical Database Technologies at Oracle. He reports to Oracle Chairman CTO Larry Ellison. Loaiza is responsible for leading product strategy, product development, product management for world's leading transaction processing and engineered system technologies and public cloud and on-premises. Loaiza holds a BS and Bachelor of Science and Master of Science degrees in Computer Science from Manchester University and Technology, MIT. And I think important bit is when you look at the introduction video, he's working Oracle database since 1988, implemented SDA memory management, shared SQL, creator of SQL trace, inventor of wait events, wait classes. Hope you guys all know it's very, very close to our heart, right? So creator of maximum availability architecture, inventor of blockchain and database. So he has more than 100 patents. So I'll stop here because I can talk for next 15 minutes. So with that, very, very warm welcome to Juan Loaiza as well as Maria, and thank you for your valuable time spending with us, especially the AIOG community. Juan, over to you.
All right, thank you. So I'm very happy to be here today with AIOG, and it's even better that I don't have to fly 28 hours to get there and then fly all the way back. So it allows me to get to do these conferences much more easily. So I like that. But I'm very happy to speak to your audience. And let me see if I can do the others. Stop screen sharing. Okay, so if you guys stop screen sharing, then I can start screen sharing, I think. There we go. So I'm going to share the screen. And this is our talk today. Does that show up okay?
Yes.
All right. So I'm going to be doing this together with Maria Colgan, we're gonna do this presentation together, and really the goal of this presentation is to talk about some of the database trends that we're seeing, and what we're going to talk about is technology innovations that create database trends. So that's kind of the theme of the presentation. And we're going to talk about how some of these trends are good, some of them are bad, and some of them are really ugly. And we're going to look at some well-known examples and talk a little bit of detail. So let's get started here. So with our first one.
All right. So the first one we're going to look at today, Juan, the first technology innovation that is cloud.
Great. Cloud.
And so with cloud, what are we talking about? Well, we're talking about having compute and information services delivered on the internet. So instead of you handcrafting these solutions, this infrastructure in your own data center, you can simply and quickly deploy it on the cloud.
Right. So Maria introduces the technology innovation, and then I talk about the database trend. And we're starting off with a really, really easy one, but it'll get a little more complicated as we go on. So the technology trend is cloud. The corresponding database trend is database running on cloud. It's pretty straightforward. And what you get is the complete automation of the infrastructure for databases and the database lifecycle. So that's some of the big benefits. So now let's see what you think about cloud databases.
Right. So we want you to think whether or not you think having a cloud database is a good or a bad idea. And then we're going to share with you what Oracle thinks. So we'll just give you a second to think about that. And then Juan, do you want to share with us what Oracle thinks?
Well, no big surprise. So again, this is the easy one. It gets harder from here, but we're starting off with an easy one. So, cloud database is obviously a good thing. Now, with Oracle, we're not just doing a cloud database. We're taking it to the next level with optimized infrastructure. So, more specifically, we've been developing our Exadata platform for about 13, 14 years. And, we've turned that into a cloud platform that's extremely powerful with a lot of scalability, availability, security, cost effectiveness. And you can bring your existing database licenses to it. So we've taken the concept of cloud database and we've taken it to the next level with a truly cloud that's really designed and optimized for database. Now, not everybody can move to the public cloud for various reasons. So we also introduced something called Cloud@Customer. So this is pretty unique to Oracle, where with Cloud@Customer, you can make deployment in the cloud super easy because Oracle brings the cloud to you. So you move your databases into Exadata Cloud in your own data center. And we've gone through 2 generations of this. One's called Gen 1. This one's the current one that we've had for like a little over 2 years, I think. It's a Gen 2 Cloud@Customer. And, it's pretty straightforward. The idea is bring that public cloud technology, simplicity and elasticity into your data center. You get database as a service, public cloud hardware, software, and APIs, operational model, financial model, and interoperates with the public cloud. Now, as I mentioned, we've been doing Cloud@Customer, I think about 4 years. And this is a very successful product. We have a lot of customers all over the world running Exadata in the public cloud and also Exadata in Cloud@Customer. One very big public one that we've talked about is Deutsche Bank, one of the biggest banks in the world. But we have maybe 30 other banks running Cloud@Customer, and not just running, but running their most mission critical applications, things like actual financial trading, regulatory, that kind of thing, the ultimate most critical application. So that's really the beauty of the Oracle Cloud and the Oracle Cloud@Customer is you can run the most mission critical, the most highly available, the most secure applications with very little work with the Oracle Cloud and Cloud@Customer. So first trend was cloud. What our database trend was, we're bringing our full technology with Exadata and our Oracle database to public cloud and Cloud@Customer.
All right, so let's move on to technology innovation number 2. and that's hyperscale computing. Now, hyperscale computing has been driven by a lot of the internet companies who needed to run giant distributed sites that offered extreme scale and also helped them deal with the more recent data sovereignty regulations.
All right, so that's the technology trend is hyperscale computing. Now with that, the first thing that spawned was actually NoSQL databases. So some of these very large internet companies kind of built their own databases they call NoSQL databases. And the goal of this was to have extremely scalable, and the way they made them scalable is with something called a sharded architecture. And what sharded architecture means, instead of having one giant database, you create many, many smaller databases. Those are called database shards. And you store the data, you distribute the data by some key, like for example, user ID. Like for example, everyone whose name starts with A is in shard 1, everyone whose name starts in B is in shard 2, that kind of thing. It's a little more complicated than that, but that's the concept. The other thing they did with their NoSQL databases is they got rid of the whole concept of transactions, since that kind of complicates availability, and that made them more available. So that's kind of what the NoSQL thing, it came from that whole hyperscale thing. All right, so now let's see what you think about this. This one's a little tougher. What do you think of NoSQL databases?
So go ahead and vote there in the chat. I'm keeping an eye to see. Oh, interesting. So a lot of folks voting that they're a good idea, Juan. So
Okay.
do you want to share with us what Oracle thinks of NoSQL databases?
Well, it's a little mixed. We like the idea of sharding, because to me, the key idea of NoSQL databases and the key benefit of NoSQL database was this whole concept of sharding for hyperscale. However, we don't really like all the limitations that came with NoSQL. Like, for example, no ACID transactions, you can only do key value, all that kind of stuff. So what we did is we took the idea, the core idea, the core good idea of NoSQL, which was sharding, and we built it into the Oracle database. So we've added something called native sharding. This makes it easy to get the same kind of benefits, the pluses of the NoSQL with all the pluses that we built over the years from our SQL database. So things like data sovereignty, massive scale using native sharding. So you can break up a large Oracle database into a farm of smaller databases. And these can be placed in different countries or regions to satisfy data sovereignty, which is a topic which is going to continue to come up more and more as there's more and more regulations about data being local to a specific country. And the way this works is all of the database shards are fully isolated. So you get linear scalability of both data and users. Oracle will automatically route a SQL operation to the appropriate database shard based on the shard key. If the SQL operation is not specific to a shard, we'll run it across all the shards. And this is very key because this was the hardest part. When people built NoSQL databases by hand, they found that the hardest part was adding and reorganizing shards. It wasn't actually, breaking up the databases. It was then, hey, if you ever have to reorganize or add shards. So we built that technology into our sharding. So you get all the benefits of sharding with all the benefits of a mature SQL database. So we've had our native database sharding available for, I can't remember anymore, maybe 4 or 5 years. And it's been matured quite a lot. And at this point, we have some of the very largest companies. We have very large internet companies running with Oracle native sharding. We have some very large banks running with native sharding. We also have some very large telecoms running with native sharding. So it's been a very successful, and there's also a bunch of, like, for example, advertising, that kind of stuff going on with our native sharding. It's been very successful, and the product has matured quite a bit. And yeah, we're running extraordinarily large workloads. So we took that core idea from NoSQL database, which is the good idea, the sharding, and we left some of the bad ideas behind, and that's what the native sharding in Oracle database is. All right, let's go on to the next technology innovation.
All right, technology innovation number 3 is microservices. And with microservices, what we're going to find is that applications are written as independent services. So each module inside of the app becomes an independent service. And this allows each of the development teams to rapidly develop and deploy their microservice independent of the rest of the application. And this allows for greater agility as services can be developed and deployed as well as updated independent of one another.
Okay, so the microservices trend is a high-level trend. It's, of course, started a database trend. And the database trend was that each microservice gets its own independent database, its own separate independent database. So let me know what you think about that.
So are microservices a good or a bad idea? I'm watching the chat. We're getting a mix of good and bad coming through. Several bads, some goods too. All right, Juan, why don't you tell us, what does Oracle think of microservice architecture? Is it good, bad?
Yeah, see, again, this gets a little more difficult. So overall, microservices we think are good. I mean, they can be over implemented many times. Sometimes people go crazy with it and they kind of hurt themselves by doing that. But the general concept of a microservice, I think, is a pretty good idea. Now, remember, the database trend was to create a separate physical database for each microservice. And in general, we don't think that's a good idea because that creates a lot of extra work for users. So database trend, separate database. The problem with separate database for each microservice is now you have to administer, secure, tune, patch each of these databases separately. So if you have an application that has 50 microservices, suddenly you got to have 50 databases you got to deal with. And that's not a lot of fun. And it's kind of painful too. So we have an answer for that, which is our pluggable database technology. So we want to make it simple with this, for each microservice to store its data in a logically separate database. We call that a pluggable database. But these are logically separate, but you can physically put them together. So the idea is that microservice can be developed as if it was a completely separate physical database. And this allows developers to focus on the application logic. But these pluggable databases can be easily physically combined into fewer physical databases. And you can do this anytime you want to. You can move these pluggable databases around between physical databases, and you can do that for many reasons. You can separate them to improve isolation. You can combine them to decrease administration burden. So you get to choose. So the developer uses a logical pluggable database, which is a logically separate database, but it's not necessarily a physically separate database. It's a little bit like containers in OS, that it's much more lightweight than a separate physical database or physical OS. Okay, so that's the microservice.
So let's move on to technology innovation number 4, which is event platform. So with event platforms like Kafka, they've become incredibly popular for application developers and architects to use when they're building microservice applications. And with the event platform, it allows the app to publish events that microservices can then consume in an asynchronous fashion. So Juan, what's the database trend that this has spawned?
Okay, so once you've created this event platform, that's how you essentially implement most microservices. Now, what happens with database is the application writes event handlers. So they use events to trigger changes in the database. So you write an event handler for each microservice that consumes events from the event platform and makes changes to the database. These handlers can also create more events. So now that's a fairly simple database trend. So let us know what you think about these.
So don't forget, let us know in the chat, are event platforms good or bad? Oh, a lot of votes for good so far. Still all good right now in the chat. So Juan, do you want to tell us what Oracle thinks of event platforms? Are they good or bad?
All right, so we'll have a little bit of suspense here. Good or bad? All right. Well, it's a little bit of a mix. The concept of an event platform we really like. However, what happens with these event platforms when they're talking to databases is that the person who writes the event handler has to code for all sorts of failures. So that gets very complicated. So we don't like that aspect of event platform. So the general concept, good. The actual implementation, it gets very complicated. So again, when you get an event, that event has to be applied to the database. And when you do that, you have to make sure you preserve data consistency, both between the event platform and the database, and also across the different services. And this can get complicated because you have to worry about things like process and network failures, other changes that are occurring concurrently. If one of the databases gets restored from backup, if you have some kind of disaster failover, the event platform gets separated from the database, that kind of stuff. And anytime you have data divergence in the databases, that tends to cause more divergence over time. Now, for a simple case like an event publish or consume case, even for those cases where you have an event, you're trying to consume it and apply it to the database, the writer of the event has to manually track the state of event consumption and store it in the database in case there's some kind of failure. It knows where to start again, what it's done, what it hasn't done. When it gets more sophisticated, when you have multiple events and database operations, for example, you might consume an event, produce 3 events, that kind of thing. Then maintaining consistency across those. So let's say I consume an event and I produce 3 more events. Maintaining consistency across all 4 of those and making sure that they all happen atomically or not gets very, very complicated. So that's really the issue with these event platforms is, for the simple cases, they're kind of okay. The more complicated you get, the more difficult it gets to deal with all the failure conditions, and they have to be hand coded. Okay, so now there's newer versions, the latest versions of event platforms like Kafka, they talk about how they support transactions. So, the solution to all this stuff to Atomicity is transactions. But the trouble is that they only support transactions within the event platform. So if you're moving an event from kind of one place to another place in the event platform, then that's transactional. So really it works well for very simple event propagation. Now, for events that make changes in the database, it's generally simpler and more reliable to use database native transactional events. So let me explain what that means. So Oracle has a capability called transactional event queues. Now, transactional event queues, it's a free event platform that's built into the Oracle database. And it's actually been an Oracle database for over 20 years. It was previously called Advanced Queuing, AQ. AQ is basically an event platform. It's queues, but also events. And TQ, this transactional event queues, is in use by thousands and thousands of enterprise customers to date. Some of the most important apps in the world run using TQ. For example, anyone who's running Oracle eBusiness Suite makes extensive use of queues in Oracle database because that's the event platform that they use. Now, how does this help? If you use transactional event queues, then when you publish and consume events, that publishing and consuming event is transactionally integrated with the data changes made by those events. So you can handle the simple cases and you can handle the complex cases like consuming an event, producing 3 more events, all that kind of stuff, and having the whole thing be automatically transactional, automatically atomic, all that kind of stuff. So it handles all these difficult cases. It provides exactly once semantics. So if you read about event platforms, they talk a lot about exactly once, at least once, only once, all that kind of stuff. With transactional event queues, you get exactly one semantic, and you get it without the complexities and downfalls of two-phase commit or having to write everything you do with idempotency. And with transactional event queues, the security, backup, recovery, et cetera, of events are tied together with the data, so they can't be separated out. And the big difference between advanced queues and transactional event queues is that transactional event queues is that scale-out architecture. It actually uses kind of a sharding of event queues. And based on the scale-out sharding that happens under the covers, it can process over 1 million events per second. So it's very high throughput in the latest releases like 19C. You can also have TQ reliably propagate events across databases. So if you have a bunch of databases in an application using microservices, it can reliably propagate these events, again, without two-phase commit. Now, most people use something like Kafka. So there's something called a Confluent. Confluent's one of the main vendors that ships Kafka. They've written something called a connector, and we've integrated with that so that it can propagate events between Kafka and TEQ and back. So that makes it simple to interoperate between Oracle transactional event queues and Kafka. Okay, so that's Event Platform. So Event Platform is great. If you can make the Event Platform transactional, atomic, and integrated, that's even better. And that's what Oracle has.
So let's move on to technology innovation number 5, which is using JSON as a standard data format. Now, oftentimes developers want to use a very flexible data model. They don't want to waste a lot of time at the beginning of a project trying to declare a fixed set of tables or columns, or basically defining a fixed schema. They want to store and access data using the exact same format they use in their application inside in the database.
Okay, so that's the technology trend. Now, the database trend that goes with that is a non-relational database that's specifically designed to store and query data as JSON documents. So that's the kind of the database trend that goes along with that.
So this is your opportunity to vote again. Don't forget to take advantage of the chat and let us know, do you think document databases are a good or a bad thing? Lots of good so far, some yes and no's, but mostly good, still a few mixed. But yeah, lots of people voting that document databases are good. Oh no, now we get a flurry of bad. It depends on their functionality. So Juan, do you want to tell us, what does Oracle think of document databases?
Drum roll, what does Oracle think of document databases? Well, we like the idea of JSON data, but a document-only database, yeah, it's very restrictive. So the idea that we had is like, again, let's take the good part of this. The good part of this is the flexible JSON format, the schemaless programming. So what we've done is we've built that into the Oracle database. So you can use JSON and XML documents directly in the Oracle database, and you can mix JSON and non-JSON data types. Now, a lot of the advantage, you get transparent scale out, and you get full ACID transaction. So sometimes the document databases have ACID, but only within a shard. With Oracle, you don't have to think about what's in this shard, what's in that shard, all that kind of stuff. You can index any JSON element. You can run parallel SQL analytics on all formats, including the JSON formats, and you can run complex joins across multiple JSON documents. So you get all the good stuff. Also, you also get JSON APIs like Mongo API. So you get all the good stuff of JSON-only databases, but much better because you get full transactions, full indexing, full parallel SQL, all the other benefits of Oracle. So take the good idea of it, combine it with all the good stuff in Oracle database, and that's what we've given. Now, Maria, why don't you show us an example of how JSON works in the database?
Sure. So in this example, what we've done is we've created a table called menu items that has just 2 columns. The first column is the restaurant name, and that's your typical traditional relational data that we're storing in there, just the restaurant name. The second column is the menu items, which are being stored as a JSON entity. And so if we look inside, what we see there is they're pretty standard JSON documents, a set of key value pairs stored there, things like the ID number for that particular menu item, the name and the price, and so on. So very easy for you to create and store JSON documents along with relational data within the same table. Where Oracle sets itself apart is just how easy it is to access the individual elements inside in those JSON documents, because you can use our very simple dot notation to access the individual elements inside in your SQL statements. So that way we can select individual elements, we can join or aggregate across those individual elements. And we do that, as I said, using the same dot notation that we would typically use to identify a particular column in a table. So in this example here, we're using M as the table alias for our menu items table. So it's m.json column name. So in this case, that's our menu item, and then another dot, and then just the individual element name that you're interested in. So here we're selecting the name and the price out of each of the JSON documents inside in our menu items table. So very easy, very slick way to adopt JSON inside your applications. Very easy for both the developers and for those of us that are more SQL heads that would prefer to write everything in SQL.
Yeah, so I think we introduced JSON in release 12.1, which I can't.
12.1, yeah.
Was that about 6 or 7 years ago, something like that?
Yeah, crazy to think, but yeah.
So, and we have a lot of focus on JSON in the Oracle database, so we're continuously enhancing it. So this example here is a very, very simple example. There's a lot of very sophisticated capabilities that we've introduced in Oracle database around JSON, and we're working on even more. And I'm not going to talk today about future releases, but we have major projects going on to do amazing things with JSON. But already what we have, for example, in 19C is way advanced JSON, far more, actually, it's better JSON, a lot better JSON than what pure document databases like Mongo does. So even if you consider just as a pure JSON database, we're better, plus we get everything else with the Oracle database. So it's a big focus, but surprisingly, there's still a lot of members of the Oracle community that don't really know that JSON exists in the database. So we always want to keep talking about it to make sure that the word gets out. Hey, if you want the best JSON databases in the world, actually, that's the Oracle database. Okay,
so let's move on to technology innovation number 6, which is the use of machine learning for analytics. Now, if you're not familiar with it, machine learning lets us solve analytical problems and identify patterns that were previously very difficult or impossible to find. So we're talking about using machine learning to do things like anticipate your customers' behaviors, figure out which customers may be walking away from your company or your site, making sure you can retain them, the ability to detect fraud while we're doing transaction processing, or to do personalized shopping or personalized ads for your particular customers based on their previous behavior. And when we are talking about this technology trend about machine learning, we're talking about using it for business data here. We're not really talking about image processing or speech recognition or use cases like that. So Juan, what database trend has machine learning introduced?
Okay, so what's happened with machine learning, of course, is we have new data platforms that are specialized to run machine learning. For example, Spark has a lot of specialized machine learning stuff. SAS has a lot of specialized machine learning stuff. So that's kind of the new trend in databases, specialized machine learning data platforms.
So we want you to vote. Do you think specialized machine learning data platforms are a good or a bad idea? Oh, very good, somebody thinks. Lots of goods following that too. Great, even. Lots of greats now, and several goods. So overall, I think I've just counted 2 bads so far. It depends on the use case of machine learning is one of the answers that you've gotten. So Juan, what do you think?
Probably a pretty accurate answer.
Sorry, not you. Sorry, what does Oracle think of specialized machine learning data platforms?
Okay, so Oracle thinks specialized machine learning data platforms for business data, and I want to emphasize business data. We're not talking about things like finding cats in videos or anything like that. Not the kind of multimedia stuff or speech recognition, but for business data. Like a lot of things, it's a lot easier to bring the algorithms to where the data is in the database than to take all the data out of the database and move it into a separate platform and continuously keep moving it there, keeping it secure, keep it up to date, all that kind of stuff. That gets very painful. So what we've done is we've implemented machine learning inside the Oracle database to make it simple to make data-driven predictions using machine learning. And it's all done using declarative SQL directly on the business data. So we have over 30 database parallel algorithms. It's parallel scalable ML algorithms. So these include things like real-time recommendations, fraud detection, customer segmentation. So you don't have to do all the work, stand up another platform, constantly move the data, make sure it's all secure, keep it up to date, convert the formats, all that kind of stuff. The other thing we've done recently is we've integrated our machine learning in the database with R and Python to make it easier for data scientists to use the database as a high-performance ML engine. Now, until about a year ago, this was an extra priced option in Oracle, but now in database machine learning is free in all database editions, including in standard edition and XE. So all of you can go out and try machine learning anytime you want to. Now, I recommend you use our latest 19C database to do it. Now, to make ML even easier, we've recently introduced something called AutoML, automatic machine learning, from Python and through a no-code interface in our autonomous database. So Maria, why don't you tell us a little bit about this AutoML capability?
Sure. So with AutoML, you tell Oracle what business question or prediction that you're trying to answer. And you also give us the data set that you want us to work on. And then the database will automatically identify the appropriate algorithm that will best predict that outcome for you. And we'll determine which elements inside that data set will help us best predict that outcome. Once we've got the correct algorithm and data, we'll also fine-tune the model parameters to get the best possible performance for you. At the end of the process, we'll actually give you an ordered list of each of the models that we tried and the probability that they will actually be able to successfully predict exactly the business question that you're asking. That way you can always utilize the model that best suits or fits your particular needs.
Yeah, so this is very cool. So we've been working on machine learning for a long time. Actually, it's a little known thing that Oracle worked on. And a lot of the algorithms used to be called data mining. But in addition to that, we've added a lot of new algorithms that are deep learning based also. And the hard part of these things, these algorithms are actually quite complicated, and figuring out how to use them is quite complicated. So auto machine learning is a big deal. So for example, let's say you're a telecom and you're trying to figure out, who's not renewing their contract, right? So you say the outcome you're trying to figure out is people who aren't renewing their contract. So you have data and say these people didn't renew their contract. With AutoML, you can give it that. You say here's the outcome I'm trying to predict, who's not going to renew, and then you give it a bunch of data on what about those customers, and the AutoML figures out what parts of this data predict that outcome. So what predicts when someone's going to drop the contract? Is it that they're not using it very much? Is it a geographic location? Is it an income? Whatever it is, it actually looks through all the data, applies all these different ML algorithms, looks at the different features and figures out what best predicts this. And that's very valuable data in that example for a telecom, but the same thing applies in any other industry. Who is most likely to buy this widget? Who is most likely to commit some fraud? So AutoML, so lots of very sophisticated machine learning technologies in Oracle database. It's now completely free. You can just use it. You use it just using SQL. We now have some very nice GUI screens also, and the AutoML capability makes it dramatically easier. You don't have to be a total ML math wizard to figure out how to use this stuff. Okay, next one.
Okay, let's move on to technology innovation number 7, which is blockchain. So with blockchain, what we'll find is that we may not find what it is.
Sorry, need to get to the next slide.
So as I said, technology innovation number 7 is blockchain. And blockchain is a ledger whose records are cryptographically linked to resist any unauthorized changes and provide a verified history of any changes that are made to the data. Now, typically with blockchain, we do require a consensus among all of the participants before a change can be made. Now, this technology was originally designed to serve as a public transaction ledger for Bitcoin or cryptocurrency. So Juan, what database trend has blockchain triggered?
Okay, so the trend is an emergence of a bunch of distributed blockchain platforms. So these are specialized platforms that hold blockchain protected data and run blockchain-based consensus protocol.
So we want you to vote. Do you think distributed blockchain platforms are a good or a bad idea? So far, we've got lots of votes for good. I'm curious if the people voting are actually implementing or working with the distributed blockchain platform, because I think it's good. It's one of those things that seems like a good idea when you're not using it. But oh, no, several goofies. Good only if you've got a distributed trust use case. All right, Juan. So what does Oracle think of distributed blockchain platforms?
All right, the drum roll, please. So let's see, what does Oracle think? Blockchain is a good idea. Now, the whole concept of multi-party consensus-based blockchain, it's very complex and very cumbersome for most enterprise needs. So when you're looking at most things that happen in the real world, there's really two parties, right? Like, for example, if I'm buying from a store, there's me as the buyer, there's the store as the seller. It's just the two of us. There's nobody else involved in this transaction. If I'm going to a bank, let's say I'm depositing or withdrawing some money, again, there's two people involved. There's me and there's the bank. If I'm using my phone, there's two people involved. There's me and there's the phone company. So that's the bulk of what happens in the world. The idea of getting a multi-party consensus every time I buy some snack at a store, I don't need 10 other people to agree for me to do that. It's just me and the store need to agree, and then I can walk away with the snack. Same thing with everything else. So in general, there is a place for multi-party consensus, but it's a bit of a niche. However, the concepts of blockchain, of crypto secure data management is actually quite interesting. So we've built that now into our Oracle database. And again, like all these things, we only have time to kind of talk a little bit about this thing. But the idea is we use these blockchain crypto algorithms to help identify and prevent fraud. So the idea is we built something called a blockchain table that detects changes by computing and safely storing a cryptographic digest of the table. And then if someone illicitly changes the table, then it won't match the cryptographic digest anymore. And so the beauty of the blockchain, the cryptographic digest, is it's immune to any kind of attack. So even if someone takes over the database, takes over the OS, takes over the machine, takes over the data center, they can't change the data without it being evident in the crypto secure database, in the blockchain table. So there's no level of privilege that lets you circumvent the math underlying cryptography. Cryptography is just math, and there's nothing you can do. I don't care what privilege I have, I can't change the laws of math. So that's kind of what it's based on, and that's what we've taken. We've taken that idea of crypto secure management and built it into the Oracle database. So Maria, why don't you talk a little bit about how that looks like inside the Oracle database?
Sure. Blockchain tables are incredibly easy to use inside the Oracle database. You simply add the keyword blockchain to your create table command. And what you'll actually get when you create that table is an immutable table or an insert only table that has each of the rows in that table automatically chained so that they to the existing cryptographic rows. So basically you add the keyword blockchain, we're going to create the table, and then newly inserted rows into that table are going to have a cryptographic digest automatically computed for each of those rows. Now that digest is based on the new row content, but it also contains the crypto digest from the previous row. That's what actually establishes the links in the chain. Basically, we're linking the new row with the previous row, allowing us to be able to instantly identify if anybody attempts to modify the data in the chain, because as soon as they do, they'll actually break that cryptographic chain. And you're able to run verification on this by taking advantage of the new built-in package inside in the Oracle database called DBMS blockchain table. In there, there's a procedure called verify rows. What that'll do is it'll run through, recompute the cryptographic chain, make sure that it matches each of the rows in the table. If it comes across a row where it's got a problem, it'll automatically stop. It'll tell you exactly how many rows in the table passed verification, and basically where it stopped, where it could no longer validate. So that'll let you know if there's been a problem in the table and exactly which row that problem has been had on. Now, if you don't trust to do your verification inside in the Oracle database, Oracle has published an open source library that allows you to run this verification process outside the database. So you can read the chain data and verify the crypto digest from outside of the database if needs be, just to truly validate that nobody has been interfering with the data in your blockchain table.
Yeah, so this is great. This is one of my favorite features these days. So we introduced this in the Oracle database in early 2021, and it's now been available for a while now. And this is a technology that we're continuing to enhance. So we only have time to talk about the most basics of this in this talk, but there's a lot more sophisticated techniques for the blockchain table that you can find out about. And we have some other videos and a lot of documentation on this. And we continue to enhance. You're going to see a stream of very cool technology come out of Oracle for blockchain table. And again, what I believe is that the blockchain technology comes kind of in two parts, right? There's a multi-party consensus based, which is what you hear a lot about. It's kind of, they talk about that sometimes as decentralized, and that's very useful technology. But frankly, it's a niche technology. Most everything you do in the world doesn't involve or need the consensus of lots of different people. Generally, there's kind of a consumer and a producer. You agree, the consumer agrees with the producer, and the transaction is done. So for most business cases, we believe this kind of blockchain table in the database more than satisfies the requirements. It's dramatically easier. And the nice thing about this blockchain table, like Maria showed, is you don't have to do a whole lot. You just declare the table a blockchain table, and then you just do normal SQL. You do insert, update, all that kind of stuff. Actually, you can't do update. You do insert, select, and Oracle takes care of all the blockchain stuff under the cover, so the application doesn't have to change. So very cool technology, again, introduced into the Oracle database and absolutely free, no charge. So you can use this just like any other table.
We did get a question in the chat, Juan, before we move on, just asking for a quick example. Do you know any examples of where blockchain has been used?
So blockchain has a lot of different use cases. A lot of people are using it for tracking origins of things, tracking authenticity. For example, if you have an educational degree, educational certificate, that something that you think comes from a source actually comes from that source. So there's a number of different use cases. We are right now engaged with several banks about adopting the blockchain technology internally. And there's really two use cases for blockchain. One, probably, in fact, the most important one is to detect internal fraud. So one of the things that's difficult is you might be a bank and you have these big, security all around you, but you have thousands and thousands of employees. And at some point, you're going to get someone who's a rogue employee who's going to try to do something bad. So that's actually a very interesting use case of the blockchain technology, is to say, hey, when rows are immutable, nobody can change them. If anybody messes with it, we will detect them. And you see that stuff with governments also. When you get fraud, many countries have fraud. So one of the nice things about blockchain is once the records go in, they cannot be changed. No authority in the world can change the laws of mathematics. So it's useful for that kind of stuff, also for detecting and preventing fraud. So I think it's very early on in the days of this technology. Like I mentioned, we just introduced it in 2021. But I think we're going to see, as people understand it and adopt it, we're going to see a lot of applications because it's very simple to use. It's really just a database table, and most of the work is done under the cover. So it's extraordinarily easy to use. In contrast, a multi-party consensus-based blockchain is a huge amount of work. It requires new applications, all these different coordination among different people. So it's dramatically easier. Okay, we need to move on before we run out of time.
Okay, all right. Yeah. So let's move on to technology innovation number 8, which is the Internet of Things. So with the Internet of Things, of course, pretty much all assets and devices that we carry around today are connected and are sharing data. So everything from our phones, our tablets, to our smart meters, whether they're for water or electricity, even our cars and fitness devices are all generating vast amounts of data. And in order to actually maintain a competitive edge, businesses are having to rapidly analyze all of that IoT style data. So Juan, what kind of database trends has the Internet of Things introduced?
Okay, yeah, I'm going to go through this pretty quick because we're running short on time. So one database trend is in-memory databases for IoT. So the reason people like in-memory databases is because they can capture a high volume of IoT data. Because memory is an order of magnitude faster than disk or flash, which makes it kind of an ideal medium for fast data ingest. And also the nice thing about IoT is it's okay to lose some data. If you lose data very occasionally, it's not like a bank transaction or something. It's kind of okay to lose the data.
So we want you to vote. What do you guys think? Are in-memory databases for IoT a good or a bad thing? Several folks voting good right now. It was also a no, but overall positive. People think in-memory databases are a good thing for IoT. So Juan, what does Oracle think?
All right, let's see, drum roll. In-memory ingest, good. Pure in-memory IoT has the unfortunate consequence because it gets very expensive and it limits the capacity. So we like the idea of using in-memory as an ingest mechanism, but not so much as a storage mechanism. So it's kind of a good and a bad, like a lot of these things are. So what we've done in Oracle is we have a feature called IoT data streaming that enables IoT data streaming. It's called an in-memory technology for inserting data. And the way this works is that you use standard SQL insert, but instead of that inserting the data straight into the database, it just deposits it in an in-memory buffer in the database. So it's essentially an in-memory ingest. And then Oracle in the background reads those in-memory buffers and bulk loads them into the database as a background process. Now, the benefit of that is you get the best of both worlds. You get the super fast in-memory ingest. So with this technology, we can run extremely fast ingest, 25 million inserts per second on a single 2-socket server. But you get the low cost and capacity of storage of flash and disk. So, and we have an API that allows developers to check on the durability of their inserts if they don't want to ever lose data. In addition to that, we've integrated time series analytics that enables users to instantly analyze their IoT data. So we got the super fast ingest, we got the low cost, we got the high capacity, and we have integrated time series analytics. It's all part, again, it's all features of the Oracle database. It's all free. All right, let's move on.
So technology innovation number 9 is new data types. So if we look at modern apps today, they're having to operate on a very diverse set of data, everything from spatial data, document data, sensor data, as well as our traditional transactional data. And that data is going to be pulled from multiple sources, often in real time. Now, how we create value from that data is also quite different to what we would normally do with traditional applications. And that, of course, has definitely driven new database trends. So what is the trend at this time?
Database trend, again, it's a specialized database for each data type. So you get a best of breed database for each database data type. And that best of breed database has a convenient data model that fits the purpose and has easy to adopt APIs for developers to use that data model. So we have specialized database for documents, for spatial, for blockchains. We've talked about a little bit, text, graph, etc.
So are specialized databases for each data type a good or a bad idea? Let's see what the community says. So far, good. is coming back as the over mixed, mostly bad from a maintenance perspective. Some more people voting bad. Oh, goodness. All right. Some people are writing essays over there. For now, let's hear what Oracle thinks, Juan.
Mixed. Okay. So mixed. Actually, this one, remember we had good, bad, and ugly. This one I believe is ugly. And the reason is having a lot of specialized databases causes a ton of problems. So even a small application these days, a modern application, wants to use multiple data types. So you want some spatial, you want some documents, you want some text, you want some graph. So even a small application has to be fragmented across multiple databases if you use these specialized databases. And the problem with that is it fragments the data. And then each of these specialized databases also has a unique and always proprietary API. So again, that fragments development. You have to learn all these new things. And because it's a proprietary API, it locks in the application to that specific data product. And if that's not enough, you have to worry about continuously propagating changes between all these different data stores. So as someone inserts data, you have to say, hey, the spatial stuff goes there, the text stuff goes there, the graph stuff has to go over here. Now, propagating data can be done a bunch of different ways. You can do it with ETL, with replication, with synchronous links. There's a lot of different ways with various kinds of events, but all of these are inherently difficult, and all of them cause unavoidable data delays. So data comes in one database, it shows up in another database later. It's very difficult to avoid data divergence. It's always a problem. So causes a bunch of headaches. So what's the answer? The answer is pretty straightforward. Instead of running lots of single purpose best of breed databases for each data type or workload, what Oracle provides is a converged database that supports all these different things. So we talked about JSON, but we also support text. We also support spatial. We also support, all the different modern kinds of data types. And if you have it all in one database, then an app can just call SQL. You want to run a spatial query, you just run a SQL query that does the spatial operation or the graph operation. You don't have to move all your data somewhere else and coordinate and synchronize and do events across them and all this other kind of stuff, which gets very complicated. You just say, hey, I got my data. I want to run this query. I can just run a query. It's no big deal. So that's kind of the idea of what we call a converged database. It's an open SQL database. It's multi-model. It accepts all kinds of data. It's multi-workload. It does transactions, analytics, machine learning, IoT. We talked about a lot of this stuff, events, streaming, multi-tenant. It's extremely productive for developers because you can build an application with a lot less work. We have REST APIs, all that kind of stuff. And we've talked about how you can modularize using our pluggable database technology. So that's converged database. We think that's much better for all these different new types of data than standing up a separate database for each data type.
All right, let's move on quickly to number 10, which is API-driven development. And with this API-driven development,
messing you up. I think I got to get my finger off the computer. Sorry.
What it allows us to do is separate the back end of the application from the front end, and by decoupling those two, we can actually reduce the complexity because they're simply going to communicate with each other using standard API calls. So without any of those dependencies, without the front end knowing what the back end is up to, we can actually make the application much, much simpler. Now, the common API that's used is typically a REST API. And REST APIs basically are text-based stateless protocols that use a simple request and response model. They use a small set of operations like get, put, post, and delete. And they basically make communication much simpler because you simply ask and then you get a response back. You don't have to wait around. There's not lots of communication. So what is the database trend that this technology innovation has introduced?
Well, it's pretty straightforward. So we've introduced REST. REST was initially not introduced for database. It's kind of a communication API. But now a lot of people have done REST to invoke common database operations, things like select statements. You can call a select statement now with just REST. You can do an insert with REST. It's used to invoke either any SQL statement or a database stored procedure, which makes database access, very simple. So is this good?
What do you think, folks? Is using REST as a data interface a good or a bad idea? Oh, getting some greats. Of course it's good, apparently. Lots more good and bad from some people, but overall great seems to be the answer. So Juan, what does Oracle think? Is REST as a data interface a good idea?
Yeah, it's a great idea. I mean, not for everything, but for 90% of stuff, I think it can be very good. So we put a lot of work into REST. We have something called an Oracle REST Data Services, ORDS, to automate the creation of REST interfaces. So make it easy to create, to access data via these REST APIs. We automatically generate the REST API on top of, you give it a SQL, any SQL statement you want, or any stored procedure in the database. And then you can treat the database like any other REST-enabled service. You just call REST and you get a reply. And this simplifies and standardizes the API to access data. You can also use REST to call Java or PL SQL stored procedures inside the database. And you can think of this as a way to extend microservices with database functions to avoid slow network round trips. So sometimes people call this lambdas now. Hey, you call this thing that does some computation and returns right away. It's a lambda. That's what's now called a lambda. We've had it for a long time. It's called a stored procedure, and you can now call it with REST API. And this is similar to how JavaScript in the browser avoids network round trips. So yeah, REST, we believe REST is going to become increasingly popular as a database API. And again, we're doing a lot of work, and you're going to see more coming from Oracle, more innovation, more cool stuff coming with REST APIs over the next few years. Okay, we're almost done here. Last one. Last technology innovation,
self-driving vehicles. So obviously with self-driving vehicles, we're asking them to navigate themselves through a complex and changing environment to get us from A to B. The database trend one is
self-driving databases. We have self-driving vehicles, self-driving databases. They manage and optimize themselves through complex and changing workloads. So this vote's a little different, not either good or bad. But the question is, can self-driving vehicles and databases handle the complexity? Will they actually work with the complexity of the real world?
Oh, some nope, not really's. Really good idea. Fire all the DBAs. No, it's bad for DBAs. DBAs, it's going to take time. You're never going to be able to replace them. Mixed is a good idea. Oh my goodness. Okay, so there is a lot of different answers there in the chat. Maybe by 2050, apparently. But Juan, what does Oracle think? Okay, let's talk about what Oracle thinks. Well, I split it into two parts. Self-driving vehicles, I think, are going to be very challenged by the complexity of the real world. It's hard enough to drive in India if you're a human. I mean, it's not easy in the United States, but in India, it's an order of magnitude more difficult. But on the data management side, the advent of machine learning plus decades of management automation, we think are a long way toward enabling self-driving databases. And so, Oracle, as you know, has this thing called autonomous database. And we've put an enormous amount of effort into this. So the idea of it is we're trying to automate the basic infrastructure, scale out. It runs on Exadata, compatibility, a lot of the security technologies. We've automated in it, things like patching and updates, configuration, hiding sensitive data, and protecting from downtime, automating a lot of the HA and automatic recovery from failure, and automatic scaling. So a lot of work has gone into this. And, the thing that people brought up is, how does this compare to a DBA? Where does this leave the DBA? That's the key question. And the way we look at it is, there's two kinds of things that people do that are tasks that are specific to your business. So these includes like architecture, data modeling, planning, that kind of stuff, data security, data lifecycle management, application related tuning. This is a big thing, the SQL for your application, tune the application for the database, all that kind of stuff. And then service level management. These are specific to an application or a business. Then there's kind of tactical maintenance operations, things like configuration and tuning of systems, network and storage,
creating a database, patching a database, backing up a database. These are fairly mundane tasks. So what we see is autonomous database is going to relieve a lot of this stuff. So it's going to make more time for the innovation, and because you spend less time on these mundane maintenance tasks. So things like running a backup, we don't need a human to fire up a backup every night or every week. That can all be automated. Provisioning a database, again, that can be scripted. It can be automated. Patching a database, actually, that can get complicated, but it can be automated. So things like that are going to get automated. And what it does is you don't have to worry about these mundane tasks like patching. They're kind of painful. They're kind of boring. And you can focus more on things like data modeling, architecture, planning, end-to-end, working with the developers, all that kind of stuff. So autonomous database, we think is here now, and it's going to be a big benefit for databases. There's a lot of stuff. I've talked about a lot of stuff today, like JSON, machine learning. There's a lot of new technologies. So instead of spending your time worrying about patching, you can learn about how to run machine learning in the database, how to do JSON in the database, how to do IoT with the database. A lot of these technologies, blockchain, how do we introduce blockchain? How is that going to help the security of your company? So that's where we think data professionals should focus, and they should focus less on these kind of mundane things. And there's a lot to learn. We're constantly introducing new technologies. So there's a lot to do and there's a lot to learn. So I think it'll be overall a good thing for everyone. Okay, so that's it. I think we're out of time, and just as well. So the idea is there's a lot of technology innovation happening, and these technology trends are creating new database trends. Now, when you look at these database trends, some are good, others are bad, and some of them are ugly. So what we're doing is we're looking at these trends, and we say, hey, let's take the good part. For example, let's take the sharding part of NoSQL, and we'll implement that in the database. Let's take the JSON formatting part of JSON databases, and we'll implement that part. So we take the good parts, leave the bad parts behind, avoid the bad and ugly parts. Like, for example, we don't want to introduce this lack of transaction consistency, all that kind of stuff in the database. So that's what we're doing, taking all these trends. There's a lot of new technology. There's a lot to learn. So thanks for joining me today. And I don't know if we have time for questions or not, but I'm going to stop sharing. But I'm happy to take questions if we have time.
Yeah, I think, most of the questions are answered we have actually Jenny as well as Connor joined and just typing, and also Maria answered most of the questions. And I need to say, wow, I think you guys touched almost all the important technologies from Oracle. And important thing is we love this interactive session between you, Maria, and with our community in the chat. I think we want to see these type of sessions going forward. We really enjoyed. I'm sure even others, guys, if you want to respond, please respond in the chat. And it is around 10 p.m. in San Francisco. Thank you so much for spending your valuable time with us today. I know, and also thanks to Jenny as well as Connor answering most of the questions. So let's go to the next one. So sentence of the day, please take a screenshot, or you can just note down, and you know the drill, right? So we'll talk about in the next session if you're not aware of this, but at least take a screenshot and we'll explain in the next session. And it's a quiz time, right? So this is a very important one. So I need to quickly unshare so that I can run this one, because otherwise you guys will see the answers. 1 second. So it will take only five questions. It will not take much time. So please keep your mobile phones, as well as even you can use your computer. You need to go to menti.com. And you can see the code on the top of 41298045. So I'll wait for at least 15 to 20 seconds, because you need to just log into menti.com and use code 41298045. So I see people are joining. So what happens is we are going to ask 5 questions, and whoever responds first, the person will be on the leaderboard. By the way, the right answer, that's very important. So you'll be on the top of the leaderboard, And every question, it's very important to answer as soon as possible, right? Even in milliseconds, it actually counts milliseconds. So yeah, it's only, I can say 25% of the people joined. So I'll wait for 5 more seconds, then I can kickstart the quiz. Okay, I think not to waste time, so get ready your hands. Hopefully you'll press the right answer. Okay, here you go. The first question comes up. Sorry. Which of these are a cloud database on-premises offerings? And you'll see 4 options. Click on the right one.
Seems like a trick question.
So, oh, okay. See, 33 people answered right one and rest of the people. So let's see who actually answered the first in the leaderboard.
Well, I'm not sure that's right, by the way, because you talk about autonomous transaction processing, autonomous data warehouse. You can actually get those on premises on top of Exadata Cloud at Customer.
At a customer, yeah.
Okay.
So actually,
Okay.
I think the right answer there was actually all of the above. Maybe everybody got it right.
Okay.
You're making this difficult for Sai's, trying to pick a winner here, Juan.
I know, sorry about that.
No, Sanjay, I think Sanjay is the fastest, but we have still 4 more questions, right? So anytime the winner will change. So the next question comes up now.
But yeah, it is the case. Autonomous transaction processing, autonomous data warehousing can all run on-prem on Exadata Cloud at Customer.
So what is the preferable option for hyperscaling databases when you want to maintain asset properties of your databases? Okay, so 45 people answered right one. So I'm going to quickly go through the leaderboard. Okay, now. Okay, Joy. Joy is in the fastest now. So the next question. Which feature is the best? Okay, I think maybe for IoT workloads, it's suitable. Yeah. Six, 5, 4. Wow. It's, yeah. So again, 24. Let's see who's in the. So Sanjay was there, now Joe. Now let's see if somebody comes up, or is it the same person now? Oh, see, every time this changes, it is important to respond as quickly as possible. Banu. So the next one, 4 or 5. Which feature makes it easier to utilize and leverage a blockchain ledger? Obviously, right? But
That
tell
one was
people.
too easy.
Okay, let's see the leaderboard. I'm sure people press really, really quickly for this session, this question. Okay, super. Banu is still in the leaderboard. Okay, this is the last chance. So make sure that you answer very quickly. Time's up. Okay, let's see who's the winner for today. See, look at this. This is what happens, the luck, right? So Suraj is the winner. Thank you. Congratulations, Suraj. And also, we got a challenging question, Krishna N. So we will reach out to you, both of you, in a chat. So again, thank you so much for Juan, as well as Jenny, Maria, and Connor joining this great session. And like Juan, we want to see such sessions. Definitely, we really love this one. So who's coming next? So please join, take a break, quick break, and join Richard Footy. 10 things you might not know about, really should know about Oracle indexes. It's a very important session. So please join, take a break, and good night to all the speakers. Thanks, bye.
All right, thanks. It was a lot of fun.
Thanks. Bye.